Okay, good afternoon. Am I audible?
Yes, madam.
Okay, so we will continue our remaining numericals. Please write down next example. So we will continue shear stress distribution for rectangular section. Okay, so please write down example. I will also write here. Okay. A beam of span 3 meter. A beam of span 3 meter. Beam of span 3 meter carries a central point load. Carries a central point load. Carries a central point load. Central point load. Carries a central point load. Full stop. The beam section has overall depth. The beam section has overall depth. Overall depth. Overall depth 300 mm. 300 mm and width 200 mm. 200 mm. Full stop. If the maximum shear stress, if the maximum shear stress is to be maximum shear stress is to be 50 Newton per mm square. 50 Newton per mm square. Full stop. Calculate calculate the value of central point load. So this is the question. So here stress is given, and from that you have to calculate central point load. So which type of beam is given in question? Simply supported beam is given. Okay, so simply supported beam, and on that beam one central point load is applied, and we have to find out the intensity of this point load. So we will locate W, and span for this beam is 3 meter is given. Okay, 3 meter. So this is simply supported beam. So shear force diagram is W by 2, here W by 2, shear force will be there. Okay, then we will draw cross section of beam. So rectangular section is given, and the dimensions for this rectangular section is width, which is equal to how much, and depth, which is equal to how much? Yes, in question width is 200 mm, so this is 200, and depth is 300 mm. 300 mm. So that much parameters are given, and we have to find out intensity of load. So already given parameters, first we will write and then we will solve. So given tau max is given. So tau max, which is equal to 50 Newton per mm square. Tau max, which is equal to 50 Newton per mm square. Okay. So next is width of section is given 200 mm. Depth of section D is given 300 mm. Okay. Span L is given 3 meter. Now, first we will calculate shear force. So we will apply tau max, which is equal to 3 by 2 tau average. 3 by 2 tau average. So tau max is 50, which is equal to 3 by 2. And the equation for tau average is S divided by BD. And value of B and D is available with you. So we will write here 50, which is equal to 50, which is equal, sorry, 50, which is equal to 3 by 2 into S divided by 200 into 300. Okay. Now we will shift this to this side. So 50 into 2 into 200 into 300 divided by 3, which is equal to S. So you calculate and tell me S, which is equal to how much? 2 into 10 raised to 6 Newton. So that much shear force. So we will write in kilonewton. So S, which is equal to 2000 kilonewton. So shear force is 2000 kilonewton. Okay. So from this shear force, we have to calculate this load. So here shear force is 2000, and here also 2000. So if central point load is applied, so at that time RA, which is equal to RA, and this is RB. So already you know that total load can carry by A point and B point. So you have to find out W. Now you tell me how we will find out W. How we will find out W? So shear force, which is equal to W by 2. Okay. So shear force is 2000, which is equal to W by 2. So W, which is equal to 2000 into 2. So W, which is equal to 4000 kilonewton. So this is the value of load. That much load can carry by this beam. So without this, here W and RA is W by 2, and here W by 2. So likewise, you have to solve these simple problems. Okay, take screenshot. So we will take next example. Okay, please write down next example. A simply supported wooden beam, a simply supported wooden beam, of span 1.3 meter, of span 1.3 meter, having a cross section, cross section 150 mm wide, 150 mm wide, 150 mm wide, and 250 mm deep, and 250 mm deep, 250 mm deep, carries a point load W at its center, carries a point load, W at its center, at its center. Full stop. The permissible stresses are the permissible stresses are 7 Newton per mm square, 7 Newton per mm square in bending, Newton per mm square in bending, and 1 Newton per mm square, in shear, So calculate safe load W. Calculate safe load W. So here two types of stresses are given, bending stresses and shear stresses. So, and you have to find out the value of W. So first we will apply bending stress equation. So bending stress, how we will calculate bending stress? Sigma, which is equal to M divided by Z. So here rectangular section is given, and the width for this rectangular section is how much? Width for this rectangular section 150 mm, and depth for this rectangular section 250 mm. Okay. So section modulus for rectangular section, which is equal to I by y max, but directly BD square divided by 6. So Z, which is equal to B is 150 into D is 250 square divided by 6. I think 1 0 is extra here. Yes, Z, which is equal to how much? 39
1.56 into 10 raised to 6.
1.56 into 10 raised to 6 mm cube. So this section modulus. Okay. Now we will calculate moment from this stress because of bending stress is given. So sigma, which is equal to M divided by Z. Sigma is 7, which is equal to M divided by Z, and the value of Z is 1.56 into 10 raised to 6. So from this we will calculate moment. So calculate and tell me M, which is equal to how much?
10.92 into 10 raised to 6.
Okay, 10.93 into 10 raised to 6 Newton mm. Suppose we want in kilonewton meter, then 10.93 kilonewton meter. Okay, so this is the moment. Now first we will calculate load from this bending stress. So here, okay, Aditya, your answer is correct. So here simply supported beam is given. Okay, simply supported beam. And on that beam, central point load is applied W. Right? Central point load is given, na? Okay. So span for this beam is 1.3 meter. So L, which is equal to, we will consider 1.3 meter. Now for simply supported beam, moment which is equal to W L by 4. If point load is applied at that time, WL square by 4. And movement already we have calculated 10.93, which is equal to W into L is 1.3 divided by 4. So W, which is equal to 10.93 into 4 divided by 1.3. So W, which is equal to 33.63 kilonewton. So that much load will coming from this bending stress. Now we will calculate from this shear stress. So next is we will calculate from shear stress. So already you know that shear stress tau max, which is equal to tau max, which is equal to 3 by 2 into tau average. Okay, so tau max is given. Value is 1, which is equal to 3 by 2 into tau average is nothing but S divided by BD. Okay, S divided by BD. So 1, which is equal to 3 by 2 into S, we will take as it is, B into D. Width is 150 into depth is 250. So from this we will calculate S. So 1 into 2 into 150 into 250 divided by 3, which is equal to S. So S, which is equal to how much? 25 into 10 raised to 3 Newton. And S, which is equal to 25 kilonewton. Okay, this is the shear force. So this is our central point load. So here shear force will be W by 2 and here will be W by 2. So S, which is equal to W by 2. So 25, which is equal to W by 2. So W, which is equal to 25 into 2. So W, which is equal to how much? 50 kilonewton. So if bending stresses and shear stresses are given, and from that you have to calculate load. So first you calculate movement from this bending stress equation, then load. And here shear stress is given, and from that you have to calculate W. So likewise you have to solve question. Take screenshots. So we will solve next example. The same example is given. In that you have to find out length. Same value, same example also same. But you have to find out length instead of load. Please read out. Okay, I will read here. You read down. Find the length. Find the length. Find the length and point load applied at the center of simply supported beam. Find the length and point load applied at the center of simply supported beam. Simply supported beam. Full stop. The width of beam is 150 mm. Width of beam is 150 mm and depth of beam is 250 mm. And depth of beam is 250 mm. Full stop. Permissible stresses are 7 Newton per mm square in bending, 7 Newton per mm square in bending, and 1 Newton per mm square in shearing. 1 Newton per mm square in shearing. Okay, so this is the rectangular section having width is 150 mm and depth is 250 mm. Okay, depth is 250 mm. Again here simply supported beam is given and on that beam central point load is applied. Okay, so here you have to find out the intensity of load as well as the span for this beam. First we will draw shear force and bending moment diagram for this beam. Suppose this is W. Okay, this is A point, this is B point. So here reaction at A is W by 2 and reaction at B is W by 2. So from this we will draw shear force and bending moment diagram here. So at A point force will going upward, so W by 2. After that in between A to C point there is no load, so diagram is constant. At C downward W, so up to baseline W by 2 and below baseline W by 2, so you will get total W. After that there is no load, so constant, and at B point upward W by 2. So this is the shear force diagram. And bending moment diagram for this only triangular. Okay. So bending moment diagram is likewise. So we will write here values. Here W by 2, this is plus, this is minus. Here also W by 2. And bending moment for this simply supported beam is WL by 4. Okay, WL by 4. So from this diagram, shear force which is equal to W by 2. Okay, from this shear force diagram, shear force which is equal to W by 2. And from this bending moment diagram, M which is equal to WL by 4. Okay, so first we will apply shear stress equation. Okay, first we will apply shear stress equation. So already you know that tau max which is equal to 3 by 2 tau average. Okay, so tau max is given. Maximum shearing stress, how much? 1, which is equal to 3 by 2 into S divided by BD. So 1 which is equal to 3 by 2 into S, we will write as it is. B is 150 and D is 250. So 1 into 2 into 150 into 250 divided by 3, which is equal to S. S which is equal to 25 into 10 raised to 3 Newton. And in kilonewton, S which is equal to 25 kilonewton. So from this you have to calculate load. So shear force which is equal to W by 2 according to this shear force diagram. So S is 25 which is equal to W by 2. So 25 into 2 which is equal to W. So here you will get value of load W which is equal to 50 kilonewton. Okay. Then next you have to calculate span. So for calculating the span you have to apply bending stress equation. For calculating span you have to apply bending stress equation. So bending stress equation is sigma which is equal to M by Z. From this equation we will calculate M and after that we will calculate L. So sigma is given 7 which is equal to M as it is, and section modulus for rectangular section is BD square by 6, 250 square divided by 6. So m, which is equal to 7 into, already we have calculated this section modulus. How much? 1 point something is there. 1.56 into 10 raised to 6. So moment which is equal to, yes, already we have calculated 10.93 into 10 raised to 6 Newton mm. And in kilonewton meter, 10.93 kilonewton meter. So this is the movement. Once you got movement, now we will apply movement formula. So WL by 4. So movement is 10.93, which is equal to W. Already we have calculated 50 into L divided by 4. So 10.93 into 4 divided by 50, which is equal to L. So L, which is equal to 0.87 meters. So likewise, you have to solve inverse problems. Take screenshots. So today we will stop here. In next lecture, we will solve examples on unsymmetric section. Please take screenshots fast. Okay, so we will stop here. Thank you for attending lecture. Thank you.